Just go through a couple of these examples here, reminding us of our strategies when solving these. It's always a good idea if we're stuck. We're off there, we're listening here now. Even if you get this completely, it's a good idea to listen. Whenever we're stuck with these, it's always a good idea to draw a diagram, okay? Identify where we think 11 pi on 6 sits. Is it bigger than 1 pi?
Yes.
Is it bigger than 2 pi? Is it closer to 2 pi or 1 pi? 2 pi. So it's going to be in my last quadrant, correct? By how much, I'm not sure. I know that this here is 11 pi on 6. I also know that a full circle is equal to
12 pi on 6.
2 pi or 12 pi on 6. Are we good with that?
Yes.
I now use that theta k. The key angle that I want in here is equal to 2 pi minus 11 pi on 6, or as Harry has so eloquently stated, 12 pi on 6. What's Harry done? He's made the denominators the same. That leaves me with pi on 6. So theta k equals pi on 6. What quadrant am I in? The last quadrant, that makes 10. So 11 pi on 6, 10 and 11 pi on 6 will equal 10. Pi on 6, correct? Negative 10 pi on 6. I go to my triangles. I know it's the 30-60 triangle. That's pi on 6 there. That's the bigger angle, pi on 3. Shortest sides always? 1. I know my hypotenuse has got something to do with 2. Last side's root 3. Tan theta equals opposite over adjacent, which is negative 1 on root 3. If you got that, that's good. Very good. There's not much more we can add as far as complexity to those style of exact value problems. So if you're on board with that, at this stage of the game you're doing very well. If you're struggling, don't panic. Plenty more opportunities to practice. Do you want me to go through these slowly or will it be quick? Maybe I'll go through this one quick and then the last one a bit more slowly. No, don't listen to mine. 5 pi on 3, that's in the last quadrant, so it's equal to sine, negative sine, pi on 3. I've already got the same triangle up. That equals root 3 on 2, so it's going to be negative root 3 on 2. Cool? And the last one, why is the last one a bit different?
It goes full rotation.
It does a full rotation plus a little bit, so I'm going to redraw this. I'm a little bit unsure, so I'm going to go back to my strategy. I'm going to draw, identify my key angle. So 17 pi on 6 is like doing a full rotation plus another fair bit of a rotation. Bigger than 2 pi, correct? Bigger than 3 pi? No, so it's going to be in the top half on the second rotation, correct? I need to identify, is it going to be the first quadrant or the second quadrant? Is it closer to 3 or to 2 pi? 3 pi, correct? So I already know it's going to be out here somewhere, correct? Let's find out how much. First thing I do, once it's done a full rotation, I can ignore that. So the first thing I do is delete 2 pi out of that. Get the denominators the same, so that equals cos 17 pi on 6 minus 12 pi on 6. You happy with that, what I've done? All I've done is just subtract 2 pi because it's going to be exactly the same thing. Once it repeats, it restarts. So that gives me cos 5 pi on 6. Are we good? Despite the fact that it's a horrible looking 5. We good with that? Now it's the same process. I might even do it over here and remember it. That's it. Yeah, you can sort of see. So I know that I've got cos 5 pi on 6. Same process. I'm now going to delete the first loop. I don't need that anymore. I just need that last bit. That last bit is equal to 5 pi on 6. What do I want to know? This little angle here, what do we call that? theta k. What's the equation for theta k? Theta k equals pi minus 5 pi on 6, which leaves me with,
1 pi on 6.
yep, for those of us who like our fractions, that's 6 pi on 6, which leaves me with pi on 6. So I need to write a line for cos 5 pi on 6, cos 5 pi on 6 equals what? What does it equal? What quadrant are we in? What quadrant? Second quadrant? What does that make cos? Negative. What's my key angle? Pi on 6, what do I do now? Go to my triangles. OH. AH. Negative root 3 on 2. If you got all of those correct, well done. You're in a great spot. There's only one more thing I can do to add complexity to that. Does anyone know what that last thing is that I can do to add some complexity? I heard someone say, make it negative. If I add a negative, we're going the other direction. Does that make sense?